Hey everybody, it's Lester Martin, developer advocate here at Datavolo, and guess what? We're up to episode number 2, Datavolo Community Broadcast number 2. Today we're going to talk about training open source vision models, and I think I know what that means. But to make it make a whole lot more sense, why don't we have our good friend Bob introduce himself in a second? He works here at Datavolo with me. I'll let him also introduce his topic, and I'll just kind of shut up and listen in for a while.
Yes, sir. So thank you, Lester. As Lester said, my name is Bob Paulin. I'm a software engineer here at Datavolo, working on a lot of ML and AI related product improvements. So we'll be talking a little bit about training vision models, open source specifically. So just a little bit about my background. I'm an Apache Software Foundation member. I help run the Chicago Java user group and also a Java Champion conference speaker. So I have some background in the whole AI thing. I mean, I went and got my master's a long time ago, actually now. But a lot of this, the AI buzz that's here now is stuff that kind of started, maybe 20, 15, 20 years ago, 15 years ago, with a lot of the vision models and the approaches that are coming out, and they've basically scaled them all up.
I'm already going to interrupt you. You said 15 or 20 years ago. So remind us what your favorite IDE is. Which one does?
Yeah, you see, I'm an Eclipse guy because I'm from the past.
Okay, I'm just messing with you. Go for it.
No, yeah, it's in a world of an IntelliJ, I still use Eclipse. So there's probably somebody that'll promote me for that. I got friends across the spectrum. I got NetBeans folks, I've got Eclipse folks, I've got you name it. I still know people using the
Yeah,
IDE.
I,
It's
I, I was going to say
it's a
you really have
religious
Eclipse.
war,
We
right?
still have Eclipse, but we still have NetBeans. Wow. Okay. All right. No hate.
It's
No hate.
Apache NetBeans now, so.
Well, there we go. Just relevant. All right. You were in the middle of something, and I just interrupted you.
Yeah, yeah. So the state of the art has kind of brought along a lot of these vision models, and part of the reason for me getting back into AI is to me it feels like it's now just starting to get very very useful to you know any application developer that's working in the space rather than a lot of niche stuff. So um, when you're working with these models, there's a lot of them that can do things right out of the box that are super useful. I've come across some table models that you throw an image of a table at it, it's going to draw the rows and the columns and find your headers for you just right out of the box because that's what it's been trained to do. But there's a lot of models out there where the architectures are kind of built where they do something very well, but out of the box, they may not fit your perfect use case for that model. So when you're working in a situation where it's like, hey, I found this model, it does the thing that I wanted to do kind of well, but I need to tweak it a little bit. Maybe there's something else I need it to pick up. Maybe there's something I want it to do a little bit better. That's when training and kind of hacking on these open source models can be a very useful tool for a developer to have in their toolbox. So that's what I'm looking to talk a little bit about today. We've done some work at Datavolo on model training, specifically around PDF parsing. So I'm going to talk a little bit about that and what we're trying to do with it. Yeah, so that's kind of the intro to the topic.
Well, intro question would be, because I hear that all the time, fine tuning that model. I mean, high level, what are we saying? Because I get the model, I get it that there's a model you throw at hey, what's this look like? Or tell me what this is. When we say fine tuning, what are we doing? Are we helping the input? Are we trying to change some code? I mean, high level, what are we trying to do when we?
Yeah, I mean, it probably helps just to kind of to roll back and talk a little bit what that term means because it can mean different things in different contexts. Like there's folks that talk about fine tuning like an LLM, like a chat GPT. When we're talking about that, a lot of times what we're talking about is providing more context for that LLM to have in order to answer our question a little bit better because maybe there's some information that is recent that it hasn't been trained on. And we're trying to provide it to that LM, like using RAG or some of the other approaches. That's one kind of fine tuning. That's not the kind I'm actually going to be talking about. The one I'm going to be talking about right now is fine tuning a pre-built vision architecture, which in this case, unlike what you would be doing with the chat GPT, just providing that context, we're actually going to mutate the model. So we're going to actually change how the model works. And it kind of helps to talk a little bit about how do neural networks work in order to kind of get build to that. And basically, a neural network is a set of inputs that can be put in. Um, Most of those, from a developer perspective, are represented as floats, and they are values that are associated to the thing that you're trying to process. So if it's an image, it could be pixels, it could be the color of the pixels, RGB values. The location of those pixels will also be conveyed to the model in a way so that, when you're reading it in, there's certain areas that are expected to receive different parts of the image. And those go through a network of connected nodes that take those inputs, and they can either decide to fire if that input meets a certain threshold, or suppress if it's below that threshold. And in order to find out, which ones fire and which ones don't, you go through this process where I'll send an input through and see what the result is. And based on that result, usually I'm starting with a set where I know what the answer should be. So I have the inputs, I have the answer key, this is what it should be. And then there's a certain amount that the model is off. And what I'm going to do is I'm going to use that to inform the model that, hey, you have to change your weights. So the weights are the things that determine, whether it's actually going to meet that activation or it's not. So that training process will go back and change how the weights work and how that model is going to eventually cause those neurons, the neural networks to fire, the neural network to fire. So the training process is really important because you have to have the right architecture, and then you want to have the right training data in order to say, okay, these are the things that I'm looking for in this image, because those will all associate to output. Because one of the outputs is going to be the level of confidence that it has that a specific class is in a certain spot. So usually with a vision model, you'll define up front, these are the things that I'm looking for. And then you're going to give me the bounding box, or basically an X, a Y, a height, and a width, of saying within this region, I have a certain confidence that this class is present. So that's what's going to be in your answer key. And if it doesn't match that, we've got to go back and we got to change some things to get closer. And this process repeats itself over a large set of data for a large number of epochs. Until you start getting things that are close to right.
So here's my question then, because well, first, good. I kind of understand that, only because I got the earlier machine learning world, and same thing. What attributes really matter and the weighting of them, and what I'm hearing is supervised learning, right? No good answer, you figure it out. What scares me though is when I think about that, oh great, I want to go build a model that looks at images of chest X-rays and see if there's cancer. We probably got a lot of good images with good answers already. But what you're talking about, I'm starting to think, oh my gosh, do we have models to help us do a good first stab at this already? Or do we have to just grab a bunch of images as humans and kind of go mark it up? I hope it's the first, or we just won't have all that large data. These inputs,
So exactly. So what you end up needing is two things. You have to have a model architecture, and for most folks that are not like research scientists like myself, we're pulling those from papers, and people are actually open sourcing these model architectures so that we can use them. The second piece is finding the data that has been annotated. So for document processing, which is one of the things we're doing, having a corpus like DocLayNet, it's an open source annotated document corpus where human beings have gone in and they've labeled certain pieces of text in the documents that match what you want this model, and in our case, YOLO-X, to detect. So you have hundreds of thousands of these examples that you're using to detect different things with your model that you're using to train. So you can get a lot of variation. It's not going to just detect one type of section header. where somebody used a very specific font and say, okay, yep, we detected a title here. You have a wide variety of documents, from forms to scientific papers to financial documents, where people have annotated different fonts and different looks. So the machine gets a lot of different examples to say this is the right answer. So that when it encounters a new thing out from the wild,
Right.
it has a reasonable shot at classifying it because it's seen so many different variations.
Excellent. Cool. Thank you. Thank you.
But yeah, supervised learning is exactly what it is. You're teaching a specific architecture to do a specific task. So when you're talking about training an open source model, I mean, you're not only just finding something that comes close to doing the thing that you want to do well, but you also have to define your classes up front, right? So our example of why we needed to train a model is we had a document model that is available, an open source one for PDF parsing, for example, exists, and it's trained on a corpus called PubLayNet. And PubLayNet has about 4 different classes of things labeled. So it'll label text, it'll label tables, titles, and I believe that's it. There might be a 4th one. I can't remember off the top of my head. But in order to do the kind of more detailed processing, we wanted to also be able to detect captions. We wanted to be able to detect page headers and page footers. So we needed a corpus that was labeled with those annotations, so that you basically draw on the screen what this section is in order to train the model on it. So you say, okay, I have 8 classes now. Here is a sample or a large corpus that has all of these classes. I send that through, a few training sessions, and then I'm outputted with a model where, and as you're doing the training, like, it's telling you what the statistics are, because typically what happens is you don't use the entire set just to train with, right? So you actually split up your training set into training data, verification data, and then also like test data for intermediate steps. So the training data, again, is the data that's used to change the weights. And then the verification data is then, okay, I changed the weights. Let's test it against a different set of data that I wasn't included in that training set, to make sure that we're able to detect things. Because at the end of the day, you don't care how well it just performs against the training set. You want it to perform well against stuff in the wild.
Right.
So you have to feed it things it hasn't seen, because what'll happen is if all you do is train it on the training set, is it becomes overtrained, and it's really good at stuff in the training set, but it can't do anything with anything outside of it.
You hit your 93% accuracy on
Yeah,
those, but then you get 28 on the other. What the hell?
exactly. So you also measure against that validation set to ensure that, all right, yep, we're looking good on stuff that you didn't train on. And that's really the metric that you're going to use in order to say, well, this is how well we do with things outside of the training set.
And how close are we trying to train these? I think of easier things like flight data and figure out if it's going to be late or not. That's probably a lot easier than an image to go, yeah, get it to 95, 97, 98. Is there a sweet spot that we go, man, it just starts to get really expensive and time consuming?
Yeah, if you look at a lot of the papers, they'll post performance data at different epochs. So every time you get through the entire training set and then do a test, that's considered an epoch.
Okay.
So what you'll end up seeing in most of these graphs is you'll see at the very beginning, they're all going up, right? Everything is starting to get better and better and better, and it's getting closer and closer with that training set. But there's a point where it just flatlines, right? Where it's like, okay, yeah, we went 100 more epochs, but things really didn't get any better, or they got minuscule, just a small amount better. And when you think about what goes into these training, you're spending money on compute and GPUs and things like that. That long line where you've been leaving things running and it gets really expensive, right?
Real quick, your boss
kind of want to
like, what are you doing over there again?
So you want to find that sweet spot where you're still getting benefit, and you're trying to get to that level that, hey, this is where customer expects the quality to be. Because at some point with any of these models, they flatten out.
Right.
Um,
Don't get any better.
so
Okay.
that's kind of and again, you'll see these graphs in the paper. So if you're using a specific model architecture, again, I don't typically design the models from scratch. I'm going to pull them from somewhere,
Hmm.
and then use a data set to make it closer. Um, I'm going to look for, okay, well, how many epochs did it take where that line starts to flatten out? And that's the time to probably shut the machine off once I'm getting that level of accuracy.
Yeah, there's never going to be that. Oh wow, spike of
Yeah, it's
productivity
generally
after it
not. I
levels
mean,
off. Right, it's done.
there are cases, in training models where you can hit a local minima.
Yeah.
Most of the model training software has enough randomness that it's going to bump you out of that. So there can be um, early plateaus that look like you're leveling off, but you're not really leveling off, that you'll bust out of. But there is, you know, for most of these, there is a case where you get to the top and it's like, yeah, we're not going to get much better. It's kind of like me. There's only so many hours in a day,
As
but
good
there's
as
only
it
so many
gets.
hours that you can actually absorb information. And then it's like, you know what? The rest of this is over
Maybe
for me.
all
We're
the
done here.
coffee, all the Mountain Dew, and all the pizza you wanted. Just that's what you get.
Not going to help. Not
Right.
going to help.
I like that
Um,
analogy a lot.
so yeah, I mean so really important to know what data that you're working with. And with these models, I think, that there's a lot of just experimentation going on where folks are messing around with this stuff. But when you're bringing that into an enterprise, you can't only just look at, hey, I just scraped a bunch of data off the web and I found this model over here. You actually have to really pay attention to the licenses, because this is kind of becoming a hot topic in
Oh,
the AI space. Is okay, you got a model, you're working it, you're trying to make money off of it, but whose data did you use in order to train that? Where are these answers coming from? Is this copyrighted information? Is this, is this, is my model going to start swearing at me? These are things that you really have to kind of worry about. So it's really important to check the licenses, of the data that you're using to train it. Make sure that it's licensed in a way that if things start coming out of that data to your customer, it's not going to be because you threw a bunch of copyrighted stuff where somebody has some hooks in you. And then obviously the model software, you have to make sure you're building on software that is licensed appropriately for you to build on. So, a lot of the licenses for the model software still kind of follow general software ones. So you see Apache, you see MIT, you see BSD,
mhm.
GPL. So those are all fairly common still in that space. But the data, there's a lot of new licenses coming out as it's evolving, just to say, well, okay, yeah, if you use this data, it's fine to use it to train things, but maybe, hey, don't republish it without permission. If you modify the data set, we expect you to contribute things back. So it's really important to
Do
read.
those crazy, not crazy, that's a wrong term. Oh my gosh, I'm recording this. Uh, do those data annotator companies play into this kind of model as well? I mean, and if so, do they? I always try to figure out how they're making money. But I know they hire all these people, they pay them $20 an hour, and they do these kinds of things. Hmm.
Yeah, I mean, so there are companies out there that sell commercial data sets, right? So there is a business around that.
Yeah,
My focus is again mostly on open source stuff.
yeah, absolutely.
So the data that I tend to lean towards. So again, like I'm going to use DocLayNet as
Hmm.
an example. DocLayNet came out of academia. So you have the data license, and I'm trying to remember the name of the it's CDLA, I believe, is it? So it's a data sharing license that's associated with that. So it gives you the right to use that data, and the things that come out of it. You're not going to have to worry about
Right.
whether you're using copyrighted stuff. Somebody has already gone through and made assurances on that you don't have to worry about it.
Yeah.
So uh, that turns out to be very, very important.
Yeah.
Um, Now, other pieces of data, if you get commercial, non-create, like the CC, the Commons,
Yeah.
Creative Commons, if you get non-commercial and things like that in there, and you're starting to use those data sets,
Your production application. Yeah.
you're starting to get into the areas where it's a little less
Yeah.
clear what what is allowed and what isn't. And I think a lot of this is going to, again, some stuff you don't really know. I'm not a lawyer until
Right.
it's all
No.
litigated, but
The first thing they learn about open source is, yeah, you got to learn all these laws. The lawyers have to weigh in. You think you read that and you go, I got that. And somebody
oh
says
yeah.
exactly what it meant.
Um, but yeah, so I mean, just to and even to get a sense of what some of this looks like, I can go ahead and share my screen
Oh,
here.
awesome. Awesome.
If you're looking at, what kind of annotated data looks like. So this is an open source program called VIA that is built for drawing these annotations. So, you'll have your image here, and then you'll have your data kind of labeled with these bounding boxes. So this is kind of an example of what it might look like as if you look at the training data, or if you get output from one of these models and then you try to reapply it. Because a lot of times, if you're trying to debug, hey, what am I finding and what am I not finding, having an annotation UI kind of helps. This is basically the image, and it's overlaid with something, a format called Cocoa. And Cocoa is a format that has bounding boxes, it has labels, there's segmentation information if you have a model that's not just drawing a box around things, but actually like shading it in. I don't know if you've seen some of those vision models where it's like there's a little kid running and the kid is blue because the model can pick the kid out of the screen. That's segmentation, where it's like multi vertex type shapes
Right.
that you're putting out there. But this is just simple bounding boxes. Bounding boxes are generally good enough for documents.
Yeah. Yeah.
So any one of these boxes I can click on and say, okay, it classified this as a page header. Here I've got some narrative text, so paragraphs, a section header here. Here's some more narrative text. Here it picked up an image.
Mm-hmm.
There's a table. So all of these bounding box coordinates basically got overlaid on this image. And if I wanted to say, oh, maybe this is wrong, I can adjust it in this software. And then, when I persist this, if I were to export in Cocoa format, this is going to store off this information in a big JSON. It's a JSON based format, and tell me, what are all the labels, where are all the segmentations and bounding boxes, by basically giving coordinates. So that if I needed to retrain my model and I wanted to put this into the corpus now with my adjusted bounding box, I could make this a part of that set and run it through the model, and in hopes that the model is going to learn and get better.
Get better next time, yeah. But it surely won't miss that one again, though.
Yeah, you hope not, right? Well, I mean, it's again, it's sometimes, hey, maybe it didn't clip it right in the right way. There's ways to adjust it, and you're giving it different coordinates, because as far as the model output is concerned, generally what you'll have is these models have different output nodes that are going to give you like, hey, this output node is associated with a specific class, which could be that image class. Now, if that node has a very high value for image, it's being rated against the other classes. So it's like, all right, image is really high. We're pretty sure there's an image here. And then you're going to have other nodes related to, okay, well, where's the X? Where's the Y? Where's the height? Where's the width?
Yeah.
So those are coming out of other outputs that are associated with that image class. So it'll say, I found something, and then it'll say, this is what I think it is. But yeah, the training process is basically being able to go through and annotate that, change your annotations, and then retrain and try to get better results.
And where are we on that kind of vision right now? Obviously, you've been talking about, we can see text, let's see tables. You showed a good example there, images. That's probably, at least in the business context, that's probably going to cover 99% of things. Or are there other, I mean, heaven forbid someone buries an audio in there. What happens? We just skip it, or do we just kind of go, hey, I don't really know what that is? Or
well, so I mean, audio would generally be a different model.
Because you're making an image out of this and then looking at it, so I don't think the audio would make a difference.
Yeah, exactly. So I mean,
you'd have an icon.
Talking about working with different formats, right? So this is a vision-based model. It's taking a PNG, which doesn't have embedded audio or anything else in it. Now, if I was trying to train something on a Word document, that looks a little bit different. Like
Right.
I actually haven't experimented too much with training a model to read a Word document, which is essentially like a zipped up XML,
Right.
um,
Which could have all kinds of nonsense in
which
there.
could have all sorts of things. Now, what I could do is I could render the Word document
Right.
to get
And
an
in that
image.
case, in this case, it would look like there would just be whatever that
Right.
visual, whatever you as a human might have seen anyway
Mhm.
in that source doc, which might just look like a speaker or something. And then that'll look
Right.
like probably a
It,
graphic test. Oh, this is
and that could those could be combined, right? So visually I see a speaker, it's in a Word document. I rip the Word document using something else like Apache Poi, which is it's a library that is good at
Mhm.
parsing Word documents. And
Okay.
hey, I found an audio file.
Okay.
Maybe I'm able to split that out, send it to a different model that can turn that
Okay.
into
See
something where
that.
I can
Yeah.
use it.
Okay.
Um,
But
Apache
yeah, I would think
Tika is
that
another
these are way corner cases in context of probably most orgs. Maybe some businesses, maybe in the the recording industry or something. That's a whole nother ball.
sure, sure.
Yeah, but
Yeah,
for
where
a
that
lot of
becomes
us,
common.
yeah, exactly, exactly. Cool, I appreciate that.
But yeah, I mean, if for example there is another type of class that you wanted to get, so
Sure.
let's say I'm trying to detect whether a document's been stamped with a stamp of approval somewhere,
Yeah.
that is different than the 8 classes that I'm going to get out, or the 8 or 10, maybe
Right.
11
Right.
classes that I'm going to get out of DocLayNet. If I needed to be able to say I need to detect the stamp of approval,
Right.
I'm going back into my vision software, into my annotator, and I
Yeah.
need examples of documents that have and don't have a stamp. And then
Hmm.
I'm going to draw that bounding box around it. I'm going to give it a specific class, which could be stamped in this case. Um, and then I'm going to take those documents and
Yep.
probably embed them into another course, because I don't want to get terrible at the other stuff that I'm already good
Right.
at
Right.
either,
Get,
right?
get too good
So
at something, you broke everything else. Yeah.
exactly. I'm going to take examples of that and try to get a sampling size where it's about the right sampling size, where I embed that into the training set,
Yeah.
and I'm going to retrain the model. And retraining the model is going to change the weights.
Yeah.
Changing the weights could make us better or worse at other classes.
Right.
So as I'm going through the training process, I'm keeping an eye on the statistics that are coming out per class, because a lot of the good models will say, hey, you're at 50% on this class,
Hmm.
60% on that class. So I'm going to look and make sure I don't degrade, but I need to get stamped, the
Yep.
stamped class up
I've
to a
defined
certain
it.
amount where it's like, okay, this is now useful to me.
Right.
And then now I have a new model that I can put in place that now can process 13 classes because I've added stamped to the classifications.
I got one more curveball for you again, and see if you got
Mm,
this covered already. What if you get some crazy stuff where these docs have them big ugly watermark or something like that? Would that be a class, or would that just be more like the vision model sees this background noise and just moves on past it and says,
it
"Eh."
depends. Yeah, I mean, so I've seen that come out
Mhm.
in like LLM software. Like it's
Yeah.
actually funny. You'll pass an image through an LLM that's there kind of where you haven't defined the classes up front.
Yeah.
So that's a different type of model, like a zero shot model is what they call it, where hey,
Okay.
I didn't define the classes up front, but I have a large and complex enough model where
Mhm.
it knows enough that it's gonna find things and pick the classification out.
Okay.
Now with watermarks, one of the interesting things is if they're really light, like they're kind of hard to see as a human being,
Yeah.
but the models, because they're a little bit more sensitive to those things, I've
Right.
had a number of models where I couldn't even see the watermark
Mhm.
without, expanding the image to a certain degree, but
Right.
it'll detect a watermark in there and will report back, hey, there's a watermark here that says
Right.
this, that
Right.
says this is a restricted image or something.
Yeah.
So if you are going to go with one of these classification based ones where you've defined the classes up front, if you don't define that class up front,
Yeah.
it could create noise where it makes it harder for detect your other classes, but you
Mhm.
won't detect watermark in those models.
Yeah.
Now a zero shot LLM that is kind of a little bit more open world,
Yeah.
it may say, oh yeah, there's a watermark here,
Probably more
where
prevalent.
you weren't
More.
even asking for that, right? It just found it.
Exactly. Yeah. Okay. I'm not going to think of anything stupid else. But that one seemed real. I could see some shops, or even
Well,
think about environments where they certain pages are like, hey, this is a special page or something, and we might want to know that, even for just ultimately for metadata or something, to say, hey, restrict this, or like you said, the restriction kind of took me down that old
Yeah, no, but that's a
show
real
top
thing.
secret,
That's a real thing where
Yeah.
people will do adversarial things to mess up these LLMs. Again, they're finely tuned to look per pixel and try to figure out, you know, what's happening in the forest based on what you're seeing in the
This is
trees, right? So
is this the injection kind of pattern? This is the
yeah, so
I'm
people
sitting you at my dog, and I just happen to know how to trick your model to do something crazy. So I'll bury that in there.
yeah.
Yeah,
So people can bury things into models where again, the
yeah,
model sees it, but the human beings don't see it.
right, right.
So you may get, hey, I detected a fox here, and you're like looking at it, it's like, where's the fox? But somebody may have manipulated again the image under the
Right.
covers to try to embed something that gives that impression without it visually
Right.
coming up to the human eye. So obviously there's things in the pixels, and usually they're working around
We solved
pixels and
those,
doing
and
something.
only knew we this is where we did our first broadcast on
Sure.
this kind of stuff. Would we try to solve that kind of outside of the model, like on the edge, and do some kind of look for things that I know are going to trip us up and solve them ahead of us, or do we need to think about
That's
them?
a good question. So I mean,
Sounds like you have to own both of them, because there's nobody can trust anyone, right? You have to, if you're producing a model, you need to make sure, well, you should do that, but in case you don't, that's on me too.
yeah, that's a great question. So I mean, I haven't done a ton of research in that space,
Yeah,
but
yeah,
I know
it's all
Sean
new.
Phillips, who spoke earlier this year at DevNexus, was talking actually about adversarial cases with models. And his finding was kind of interesting, is that a lot of times when people are trying to mess with you, whether it's text that
Yep.
may have been generated by an LLM or maybe something wrong with an image, like
Hmm.
they do them in consistent ways. So
Yeah.
there's potentially ways to cluster. Like,
Mhm.
so if you find one that's bad, another one that is similarly bad could
You build a
potentially
model that
be
finds bad
clustered close
things,
to that.
and
So yeah, if you find a clustering of bad stuff and
yeah,
you can associate other bad stuff to it,
then you
again,
catch
his
the new
theory
stuff,
is
the
that
new ones that are
you
coming,
can
right? As
catch the
long as
new
they fit
ones
into
based
that.
on clustering. So
Okay.
there are people doing research in that area, because I mean, with generative AI, you can generate images, and if you can generate them, you can, hey, please create an image that's going to mess with
That's
another
gonna
LLM,
do
right?
this later. Okay.
Yeah. So you've got to find a way to work
What a
around
brave new
that.
world we're in, man. I'm glad.
Oh, I know.
I'm happy and scared all at the same time. Every day I think about it. I know you guys have been at it here at Datavolo a little longer than me, and are definitely a lot brighter than myself. But I'm trying my best to
Oh,
catch up. I'm
please.
going to get there. Well, I'm going to get close. How
Yeah,
about
I think I joined probably 3 months ago. I'm still playing catch up. So
that? Well, cool, man. I didn't mean to kind of ride you to the end there with these weird off questions or something, but they all seem like they fit in pretty good to me in my head there, and I like the responses. I think it processes in my little simple learning model up here. So, anything else you want to kind of share about,
just
or
keep training it, man. It just keeps getting better, right?
isn't that what we
Just
do?
don't overtrain it.
At this point in my life, I don't think I'm overtraining this noggin. So, but anything else you were thinking we should cover? I mean, this is a great topic. I loved it. It's helped me a lot. Like I said, I'm pretty early in this journey. I know a lot of folks listening are probably in the same boat. They're probably catching up, like probably 99% of us are, to see what's going on, what's next. And man, good
Yeah,
stuff.
I mean, so I think the only thing to take from here is I think we covered a lot of the broad strokes. So we
Yeah.
talked about data formats, we talked about training sets, we talked about models, and specifically we talked about a couple of different kinds of vision models. The ones we're using are like one-shot detections where you do have to provide classes up front versus zero shot like LLMs where, hey,
Right.
just tell me what's in this picture. But yeah, there's a lot of follow-up stuff. So I'll definitely send some links just on
Awesome.
some of the models that and data formats we talked about just for the show notes.
Hmm.
And then going forward from that, the next step that we may talk about in the future is probably talking about runtimes and inference. So the other side is that I've generated my open source model. Now, how do I run it
Yeah.
successfully in production?
This is the stuff you just blogged about it.
This is, yes, it's something
Yeah.
I just blogged
Awesome.
about.
Yeah.
So it's
Let's
a
definitely come back. Let's
good
come.
follow-up conversation.
You are I'm acting like we've had this show for a long time. But welcome to come back anytime. You're welcome on the couch and all
Oh,
that.
thank you. Thank you.
But you are more than welcome. All right, man. Unless you got something else, I'm gonna give the old salute on the way out. And thank you so much. And
All
we'll see
right.
you.
Thank you, Lester.
All
It's
right.
good being on the show.
All right. Take care. Bye.
All right. Take care. Bye.